Hi there, I'm an old guy and I do maths. Today we're going to look at how we factorize quadratics that look like this. Coefficient of x squared other than 1, and we have taken the decision that we're not going to complete the square, we're not going to use the quadratic formula, and we can't divide through by 3. But there's something interesting about this. 3 is a prime number. 3 is a prime number. Here's a convenient list of prime numbers for those of you who've forgotten. We can turn this to our advantage. It's highly likely that the factors of this will be 3 and 1, and the factors of this will be 3 and 1, and that will give us an answer to this. So let's go ahead and try. So I've already set out a couple of brackets. You do this by trial and error, or I do anyway. Set out a couple of brackets with 3x here and x here. And what we're going to do is we're going to put 3 there and 1 there and 1 there and 3 there. This is entirely positive, so we can put positive signs throughout this. And let's just see what we get. So 3x squared plus 3x. Well, let me write this out. So we get 3x squared plus 3x, that's that 3x there, plus 3x plus 3. Now, this is what we're looking for. We've got that and we've got that. That matches that, and that's a match for that. Our problem is in here. 3x plus 3x will not give us 10x. So I don't think that's a starter. We can forget about that. Let's try this. 3x times x is 3x. 3x times 3 is 9x. This is looking promising. X times 1 is 1x. Again, very promising. 1 times 3 is 3. Tidy this up. You get 3x squared plus 10x plus 3. There we are. That's how you do that. Let's try it with one where the numbers are still prime, but slightly different. Factors of 5 are 5 and 1. Factors of negative 3 are 3 and negative 1, or negative 3 and 1. So we might wind up with a few more brackets here as we try this, but what we're looking for is we're looking for some combination that will give us 2x. So let's try this. We'll try, let me see, we'll try 3 here and negative 1 here. Okay. So all we have to do, we don't have to go through the whole business of expanding everything here. We can just deal with the x's. So negative 1 times 5 is negative 5x. Positive 3 times x is 3x. Now we're looking for positive 2x. That is going to give us negative 2x, which is no good to us. So what we're going to do is we're going to just try with different signs and see if we get lucky. This may take a bit more work than this. 5 times 1 is 5. That gives us positive 5x. Negative 3 times x is negative 3x. And that equals 2x. This looks promising. Let's just expand the whole thing. 5x times x is 5x squared. We know that this is 2x, so plus 2x. Negative 3 times 1 is negative 3. That's the one we want. Here's something a little different. Let's have a look at this. Now in this case, we have a prime number here. but we don't have a prime number here. So we're going to have to play around with some of the factors of 35. 35 and 1 is also a factor, but it's unlikely to be of any use to us because we have a 17 here. It looks like 35 and 1 would give us something way too big. So what I've done is I've just set out this again. I've taken the factors of 2, 2 and 1, 2 and 1, and then I've started playing around with the factors of 35 until I got something that I thought might just do the job. So again, what we're looking to do here, just quickly, is from these factors achieve this number. So we know that we're going to get 35 from -5 times -7, or -7 times -5. We know that we're going to get 2x squared from this. This is the thing that we're concerned with. And on my second attempt, I got this. And so I put a tick beside it, which obviously means that I've thought about it or expanded it and found that it works. But I'll just expand it now to show you. So 2 times x is, 2x times x is 2x squared. 2x times -5 is -10x. -7 times x is -7x. You can see where this is going, hopefully. -7 times -5 is 35, and that's positive. These two numbers add to 17, -17, and as you can see, that's what we get, and that's what we want. So there you are. Now, why should we test them? Well, we should test them because if we don't, we could get that. And that's wrong. It's as simple as that. So just to be certain, once you have a level of confidence that you've found what it is you're looking for, just expand it and make sure. Okay, thanks for watching. See you next time.